Hey class, this week's lecture will be on the debate on top-down influence on speech perception. If you take a look at this flow chart, what you will see here is the traditional view that most scientists have had thus far about how information is processed in the brain or mind. First, our auditory system receives sound waves, and then these sound qualities are analyzed by the brain. Remember from the book chapter that a phoneme is the smallest unit of sound that our brain can differentiate from other sounds, that when they're combined, they can form words. Well, with speech sound, after the sounds are heard, phonemes are perceived after the basic sound features are analyzed, which go on to form meaningful words. After that, these words are incorporated into any task at hand during cognitive processes. An alternative way of looking at this process is called the top-down influence. Putting it simply, this means that information from higher level processing in the mind can influence how information is processed in the lower level stages or earlier stages. So the question is whether the information coming out of the cognitive processes would be fed back down into the lower, earlier processes to affect those processes in some way. In the case of speech perception, the question also becomes this: do the cognitive processes such as decision making or other information retrieved from the mental lexicon, or in other words, your mental store of words in a specific language, does this affect the earlier and more basic processes of speech sound? The two arrows here illustrate the potential top-down influence. As you can see, they're somewhat circular there with the second and third stages. In the text, there was a reference to a study where certain words were broken up by static, but based on the context of the rest of the sentence or phrase, participants still thought they heard the whole word. So you might be saying to yourself, who cares, Dr. Frizzell? Why does this debate even matter? Well, it actually directly impacts the fundamental concept of perception at its very core. One of the basic ideas about sensory and perceptual systems is that each system, such as the auditory system, constitutes kind of a module in the mind or brain. The idea of modular functions was formally proposed by a theorist, Fodor, F-O-D-O-R, several decades ago, and it continues to be a critical concept in the study of the mind today. When we examine this theory that the mind or brain has modules, what we're saying is that there are multiple self-contained systems that are separate from all other mental processes. As a result, the module view of perception also means that there is a division or separation between perception and cognition, as indicated by the red line that you see there. Here are a few key features to think about. A module is like a set of processes that are hardwired together in a fixed organization. So the module functions as one self-contained unit, much like a mechanical module. Once information enters the module, it is automatically processed to the fullest within the module before being passed on to the subsequent stage of processing. Some argue that this is actually an advantageous way of doing things because perception would be highly efficient in time and energy. If it is not affected by other processes, the fixed sequence of processes in the module can be completed in a very short time with very little energy. To us, perception always seems instantaneous, which means that a lot has been accomplished within literally milliseconds. If top-down influence from higher level processes can influence the lower end processes within the module, then the modular nature of perception is also called into question. So as you can see, the top-down processing theory and the modularity of mind are sort of positioned as opposing theories. Despite the large amount of research being done, this debate is still ongoing, probably for at least 40 years or more now. Traditionally, researchers in the field of sensation and perception formulate theories with the assumption of the modular nature of perceptual processing. And these theories have been successful in explaining psychological phenomena in sensation and perception. The challenge to the modular assumption of perception was a relatively recent development, mainly from the area of cognitive science, where they primarily use a different theory called distributed processing. This is where different cognitive functions may share the same mechanisms or interact with one another. In other words, this cognitive science perspective is incompatible with the modular view of any cognitive function. One particular argument against the modular view of perception is the existence of top-down influence in perceptual processes. But this argument faces a lot of challenges. Let's consider a few of those challenges here. First of all, there are definitional issues, both with the definition of top-down influence or the definition of perceptual processing. Some researchers define top-down pretty broadly to include any physical or mental context, while others exclude contextual effects. The operational definitions of perceptual processing also varies from researcher to researcher, with some including conscious perceptions while others exclude those. As in many debates in science, researchers tend to have adopted a position on the debate even before conducting empirical studies. So a lot of studies were simply done to just confirm their own hypotheses. The problem is sometimes the data could be interpreted to support either position on the debate. For example, a study showed that perception of phonemes can be influenced by other words that the subjects have been exposed to. That is, you could hear an ambiguous phoneme, but then interpret it within the word level or sentence level meaning, like the examples in the readings for this week. For researchers advocating the existence of top-down influence in speech perception, this is clear evidence in their favor. However, the same data were also considered consistent with the modular view of speech perception without top-down influence if they treated the effect of context as a learning mechanism for perceiving phonemes rather than related to the perception of phonemes itself. I know this sounds confusing, but the take-home message here is that the science on this subject is far from settled if competing researchers can explain the results in ways that support their own theories. As I mentioned earlier, sensory and perceptual processes are completed within milliseconds, outside of our own conscious awareness. So, if we need a response from a subject, it requires a metacognitive process, which is basically to say a higher level of thought, kind of like thinking about what we're thinking about, in order to make a conscious judgment about the information coming out of sensory perceptual processes. It is possible that we simply have no access to those unconscious processes directly, even if we try. So we instead infer the perceptual processes from other decision-making processes, which are, of course, higher level later processes. So can you imagine how exhausting and distracting it would be if we were aware of all the lower level perceptual processes happening at an unconscious level? I think that would be pretty mind-blowing. But anyway, another idea to consider here is called phoneme restoration. The phoneme restoration effect is susceptible to this issue. When a phoneme has been omitted in a sentence, subjects report hearing the whole word where the phoneme should have been. It was interpreted as a top-down influence from the word sentence meaning to phoneme perception by some people, but other researchers explained the same finding as a post-perceptual judgment made by the subjects. In other words, they didn't really perceive the missing phoneme, but they thought they did afterwards. So in conclusion, the debate is still on. There have there's been a lot of influence supporting either side of this debate. This isn't just a phenomena having to do with the auditory system. This problem comes up with the same way, in the same way, in each sensory and perceptual modality like vision and olfaction. This also applies to different types of information being processed, such as speed sounds and non-speed sounds within the auditory system. Much of the empirical evidence is open to interpretation by the two opposing camps. Alternative interpretations are often made based either on research design issues or on theoretical grounds, but we, as consumers of the research literature and as students of the field of sensation and perception, we should always keep an open mind and consider all the issues I just mentioned in the previous slides.